Oh, good. We get to do a word problem. Here's our real life examples of where this stuff shows up in the real world. All right, so Acme Innovations makes and sells lamps. Looks like they're lava lamps. All right. Their profit, P, in hundreds of dollars earned, is a function of the number of lamps sold in thousands. From historical data, they know that their company's profit is modeled by the function shown. So our profit is in hundreds and our lamps are in thousands. I do want to underline the lamps are in thousands, just to make sure we're not losing track of that. Here's our function shown over here. So the x's as you go along here is x equals 1, 2, 3, 4. Those are in thousands. So this would be 1,000, 2,000, 3,000, 4,000. This models the profit. What do the zeros of the function tell you about the number of lamps that Acme Innovations should produce? All right, so first of all, what are the zeros of the function? When we're looking at a graph, we can tell what they appear to be. So let's make note of that the zeros appear to be at x equals, let's see, -2, +3, and +10. How do we confirm that they are actually at those values? That's just where you grab your calculator, you plug in a -2 for x, you plug in a 3 for x, and you plug in a 10 for x. So here I am plugging in -2, +3, +10. I want to confirm that those are the true zeros of the function, and if I'm getting back a 0 when plugging those values in, then yeah, those are the zeros of the function. We have confirmed that. All right, so next, whoa, there we go. All right, so let's take a look at our graph. We want to talk about what do the zeros of the function, so what is that -2, +3, and +10, tell us about the number of lamps that Acme Innovations should produce. All right, well, when our function P of x is positive, Acme earns a profit. And I think that's what we want the company to do, right? They're going to want to make a profit. That's why they're in business. So if we look at our graph, where is P of x positive? So our function, the polynomial, is positive anytime it's above the x-axis. So if I were to outline where it's positive here. Oop, I went a little too low. And it's positive here. So those spots on this graph, here's where x is a -2. So all the values to the left of -2. So when x is less than -2, our function is positive. And our function is also positive from here to here. That's our +3 to +10. And everything in between. Everything in between this 3 and this 10 is when our function is positive. So our function is also positive when x is less, or when 3 is less than x, which is less than 10. That's just that compound inequality that lets me write in one statement that our x's are between 3 and 10. That's where we are positive. All right, because x is representing the number of lamps sold, even though mathematically this is a positive interval, it really doesn't apply to this situation because you can't make a negative number of lamps. So really, this is the interval of when when the profit is positive that we can use. So the number of lamps need to be between 3 and 10, but remember that's in thousands. So Acme needs to sell between 3,000 and 10,000 lamps to make a profit.